Hello guys, welcome back to another fun math lesson. We are doing 5-4 today, which is all about inequalities in a triangle. So what are the different inequalities and I guess what are the different inequality theorems and how do we use those and what does it tell us about triangles? So we actually have 3 objectives today. The first one is to prove that the side lengths of a triangle are related to the angle measures of a triangle. Then we're going to use the angle measures of a triangle to compare the side lengths. So we'll see how are the angle measures and the side lengths related. And then lastly, we're going to use the triangle inequality theorem, to determine if 3 given side lengths will form a triangle and to find a range of possible side lengths for a third side given 2 side lengths of the triangle. So basically, if I'm given the 3 sides or 2 sides of a triangle, what are the options that I have for that third side? It can't just be whatever we want, right? We have some restrictions on there, right? Because if I have 2 sides, it can only go so far, right? Okay, so let's look at, we don't have any new vocabulary today, but we do have some theorems and postulates. So let's jump down to our theorems and postulates page and let's see what these 2 are about. All right, so here we are down at the theorems and postulates page, and there is a typo here, so I want you guys to fix this in your notes. This is not the triangle inequality theorem. So we can cross this one out. This was just theorem 5-9. So that's the converse of theorem 5-9, and then this guy is just theorem 5-9. So sorry about that, it's just a little typo. We'll add in the triangle inequality theorem here down below, okay? But here, theorem 5-9, it just says, and I'm going to draw one diagram for both of it because it's really all we need. But all it's saying is the largest side of a triangle is across from the largest angle. Vice versa, the smallest side of a triangle lies across from the smallest side of, or the smallest angle of the triangle. So here's my triangle ABC. This is the largest angle. I think we feel pretty confident in that, right? So this is the largest angle. Since that is the largest angle, across from it is side AB, so this is the longest side. And that's going to work in pretty much any triangle unless the triangle is isosceles, okay? Same thing here. This guy right here, to me anyway, looks like the smallest angle. Smallest angle. So therefore, across from that is the smallest side. And same thing like the middle angle, right, would be across from the middle length side. So that's just pretty quick and easy. It's just a fun little helpful guide. Like if I need to know which side is longest, I can say which angle is the largest. And whichever angle is biggest, I know then across from that, the side is the longest. Okay, so now we're going to look at the triangle inequality theorem. Sorry about the mix-up there. Okay, so this just says that the third side of a triangle is between the sum, remember that sum means add, so between the sum and the difference so that means subtraction of the other two sides. Almost fit it. It's okay. Okay, so the third side of a triangle has to be between, if I add up the two sides, right, that's going to be the maximum. And then if I subtract the other two sides, that will be the minimum. So I'm just going to draw a quick little triangle here. Not a very good one, but it doesn't really matter. Okay, let's say this is A, and this is B, and this is C, and let's say that side AB is 12. And then let's say that side AC is, let's go with 14. Okay, and there's lots of different possible numbers that could be the length of BC. So what we do is we take the sum. So I add these two numbers together, 12 plus 14, which gets me 26. And then I subtract these two numbers. And I always do the bigger number minus the smaller number because I don't want negatives. And I get 2. So that tells me that BC has to be between 2 and 26 units. The length of BC can be 2.000001, or it can be 25.99999, or anything in between. But it cannot be, so we're going to make a little note here, it cannot be 2, and it cannot be 26. So it can be anything between 2 and 26, but it cannot be 2 and it cannot be 26. So I have a wide range of values that BC could be. If, for example, if BC was 30, then I would not be able to make this triangle work. Okay, so hopefully that makes sense. So just to show you an example, if this was 12, right, so that's 12, and then this guy's 14. In order for it to be 30, it'd have to be like this, and it wouldn't reach. Okay. Or it wouldn't, or it would go past. Like there's no way that I can make this a triangle because it'll be too long. So that's why, excuse me. That's why we have this restriction that it has to be between 2 and 26. And so that's the triangle inequality theorem. Just saying that and you can pick any two sides. So if you're given all three and you want to check to see if you can make it a triangle, just pick 2 of the sides. But if you add 2 sides together and subtract 2 sides together, the third side has to be between those 2 numbers. So let's look at some examples of this in 5-4. And I think you'll see that it's really not so bad. So let's go back to our notes in 5-4 and look at this. All right, so here we are back in the notes in 5-4. And our first example says, which angle measure appears to be the smallest in this triangle MNP? So to me, as I look at my angles, angle N appears to be smallest. So remember that we always have to write it as 3 letters, right? So I'm going to say MNP looks to be the smallest angle. And I chose MNP, but you could have also said PNM. right? The order of that, you can go either way as long as that n is in the middle. Then it says, how is it related to the side lengths? So I'm looking at, excuse me, this angle right here. So it is a cross, right, from the smallest side. So it is a cross from the smallest side. And that is always going to be the case. So my biggest angle, which would be M, is across from the biggest side, and so on and so forth. So that is a trend that happens pretty much in all of our triangles. So let's look at another quick example like that. It says use theorem 5-9. So it says to support a triangular piece of a float, a brace is placed at the largest angle and a guide wire is placed at the smallest angle. Which angle is largest? So I need to know which angle is largest. Well, I know that the largest angle is going to be across from the largest side. So I have 10 feet, 12 feet, and 13 feet. So here is my largest side, which means the largest angle is going to be across from that right here at angle C. So I can say the angle, and again, you have to use 3 letters. So I'm going to either say ACB or BCA. So I'm going to go ACB is the largest. So that is the largest angle because it is across from the largest side. Then it says which angle is the smallest? Well, between 10, 13, and 12, 10 is my smallest side. So that means across from that, which is B, is the smallest angle. So now I can say that triangle ABC, angle ABC is the smallest because it is across from the smallest side. So hopefully that makes sense and it's not, anything too crazy here. You guys have 2 try it's. I'm going to scroll down so that you can see them. Okay, so 2 try it's here. It's just asking you what is the largest angle, what is the smallest angle, and then this one wants you to list the angles from the smallest to the largest. So you would put the smallest one first, then the middle, then the largest. Make sure that you use your 3 letters and go ahead and hit pause on this video and get it done, and then when you're ready to go over it, you can hit play. Okay, so let's look here. Here we have a garden box that Lucas is creating, and he wants to know which angle is largest. So my biggest side here is 14, which means the angle across from that is the largest. So I can say angle DEF is the largest. You also could have said FED. So the order there, okay. Which angle is the smallest? Well, my smallest side is 8, so the angle across from that is D. So now I have angle EDF is the smallest. Again, you could have written FDE, and that would have been okay too, as long as the D is in the middle here and the E is in the middle here. The next one says list the angles of the triangle in order from smallest to largest. Smallest side here is 10, so the smallest angle is N. So angle MNP is the smallest, right? Smallest. Then the middle angle would be 16, or 16 is the middle side, so across from that is M. So then I'm going to say NMP. And then my largest side is 18, so my largest angle is P. So I'm going to do MPN, and that's the largest. So you're just making a list of the smallest angle to the largest angle. All right. Hopefully that makes sense. If not, make sure you reach out, ask questions. We're going to do another example here. Here it says, which side of triangle KLM is the longest? Well, I know that the longest side is going to be across from the biggest angle. Right now, my biggest angle is 62, but I don't actually know what this angle is, what angle K is. So I have to find that. And we can call it X if you want or whatever, but remember that the three angles of a triangle add to 180 degrees. So I have 50 plus 62 plus X equals 180. So hopefully that makes sense there. So when I add these together, I get 112 plus X equals 180. Subtract 112, subtract 112, and X is equal to 10, 8, 7, 68 degrees. So I can go back and look at and erase this and plug in now what it is. It's 68. So now let's go back and look at the question, right? Which side is longest? Well, the longest side is going to be across from the biggest angle. And now my biggest angle is 68, right here. So the side across from that is LM. So we can say that LM is the longest side. So it's using the same idea. We just had to do a little bit of work to figure out what this angle was going to be first, and then we could figure out what was the longest side. Okay, so you guys have a try it on the next page, exactly the same idea, and it's asking which side is the longest and which side is the shortest. So go ahead and hit pause on the video and give that a try, and then when you're ready, let's go over it. Okay, so here's the try it that we did. Hopefully you went through this on your own and you got it and you're just checking your work here. I'm using triangle NOP for these two questions, and it says which side is the longest and which side is the shortest. Well, I only know two of my angles, so I'm going to have to find the third angle again, which we do the same method, right? And hopefully we found that this was 57 because those three angles add to 180. 57 degrees. There we go. Okay, so which side is longest? Well, the longest side is going to be across from the biggest angle. So here my biggest angle is 65. So the largest side is going to be OP. Does that make sense? We okay with that? Okay. So, or PO, it doesn't matter the order that you write it. So OP is the longest side. Okay. Then it's asking me what is the shortest side. Well, the smallest angle here is 57. So across from that would be NP. So NP is the shortest side because it's across from the smallest angle. So that's kind of all that we're going to talk about on Theorem 5-9. What we're going to do on the rest of this page is focus on the triangle inequality theorem. So we're going to kind of switch gears here. Remember that the triangle inequality theorem says that the third side of a triangle has to be between the difference and the sum of the other two sides. So here on A, it says which of the following sets of segments could be the sides of a triangle. So I'm going to notice I'm given three sides. I'm just going to pick two of them. Doesn't matter. I'm going to pick these two. But I could have picked any two, okay? As long as it's one of these three. And I'm going to find the sum, which means I'm adding them. So 19 plus 18, which is 37. And I'm going to find the difference, which is 19 minus 18, which is 1. Remember, you don't want to get negative numbers, so just always do the bigger number minus the smaller number. So this tells me that my third side has to be between, so side 3 has to be bigger than 1. Okay, well, 40 is bigger than 1, but it has to be less than 37. 40 is not less than 37, so this does not work. So this does not make a triangle because 40 is too big to be that third side. Okay, now we're gonna do it again for set 2, and we're gonna see if, does this one let us make a triangle? Again, I'm gonna just pick 2 of my sides. I'm gonna use these 2, but again, you can pick whatever you want. Okay, so the sum of these, if I add them together, I get 70. And the difference of them, if I subtract them, I get 4. So this means that my side has to be smaller than 70, which it is, and has to be bigger than 4, which it is. So this can make a triangle. So those 3 lines would be able to make a triangle. Okay, so the third side has to be between the difference and the sum of the other 2 sides. Let's look at B here. It says a triangle has sides that measures 11 centimeters and 16 centimeters. What are the possible lengths of the third side? So again, I have to find the sum. So I need to add them together. Well, if I add those 2 together, I get 27. And I need to find the difference. So if I subtract those 2, I get 5. So that tells me that the third side has to be bigger than 5, but less than 27. Okay, so it can be 26.9999999 centimeters, but it cannot be 27. So that's all, that's all that the triangle inequality theorem says, is the third side has to be between that sum and difference of the other 2 sides. So you do have a try it real quick. So there's an A and a B. Go ahead and pause the video, try it, and if you feel ready to go ahead and hit play, and we'll review it. All right, so let's look at the try it. Hopefully you did it. Remember that if you ever mess up on this, it's totally fine. Just fix it. We learn a lot from making mistakes and fixing them, so it's totally fine. Just correct the error, and you'll be good to go. But it's better to try it and mess up than not try it at all. Okay, so here it says, could a triangle have side lengths 16, 39, and 28? So I'm just going to pick 2 of these sides. Again, it doesn't matter. I'm going to go with those 2 just because they were the first ones. I don't know. The sum of these, if I add these together, I get, let's see, 49.55. And the difference of these, if I subtract them, is 23. So that tells me that my third side has to be between 23 and 55. Is my third side between 23 and 55? Yes, right? It's 28. 28 is bigger than 23, and it's smaller than 55. So can these 3 side lengths make a triangle? Yes, they can. Yes, you can make a triangle. It fits within that restriction of bigger than 23, less than 55. Then for B, it says a triangle has side lengths that are 30 and 50. What are the possible lengths of the third side? So again, we find the sum, we add them, and I get 80. And then we subtract them, and I get 20. Okay, so the possible lengths for the third side are between 20 inches and 80 inches. So any number bigger than 20 and smaller than 80 will make a triangle, with the other two sides being 30 and 50. Last one, example 5. I want you to go ahead and just do this one on your own, and then we'll go over it when you're done, but it's the same thing. Find the possible lengths of the third side of triangle ABC if A is 31 and C is 20. So remember, if you're given a diagram, you should almost always fill it in with the information you know. So go ahead and find what are the possible third side lengths. All right, so hopefully you've done it and we can just go over it now. Again, I want to find the sum. So if I add these numbers together, I get 51. And if I subtract these numbers, I get 11. So that tells me that side AC has to be between 11, and I actually know the side length name, so I can do that, and 51. So AC has to be between 11 and 51. Okay, so hopefully that makes sense on the triangle inequality theorem and how we're using that, and what it's useful for and things like that. If you guys have any questions at all, always, like I say every single time, make sure you reach out and get the help that you need. Otherwise, that's it for 5-4, and we will see you soon, and have a wonderful day.